So in this video, let's discuss the first three problems of Codeforces around Hello 2024. So we will discuss the first three problems. Let's start with problem number A. The name of problem A is wallet exchange. So simply what we can do, I think so there is no need of understanding or reading the problem thoroughly. You can just see the input output in this problem. You can see, notice one thing. If the sum of my both the numbers is even, then I will print Bob, else I will print Belize. So simply I haven't really read the problem statement itself of problem number A, because you can see it is clearly, if my both the numbers are odd, then my answer is Elias, else my answer is Bob. You can prove this, but I haven't proved this in the contest, but simply print the answer based on the A and B. Okay, so let's now turn to problem B. And similarly, this happened with problem B also. What you can do simply in this problem, you have to simply subtract the number of pluses and number of minuses. And absolute difference between the plus and minus is my answer. So you can read the problem statement and make a proof from this. But to be honest, I haven't proved this also, but only seen the input and output and simply print the absolute difference between the plus and minus for problem B also. And it worked. Okay. So main point is that in the contest you have to solve the problem fast and fast. Okay. So, but there are many cases like in problem number A and B, you can just see the input output and recheck for all the cases whether that condition is validating or not. For example, in both the problems, my this condition is satisfied. That in this problem, my difference between A and B, or I can say plus and minus, is my answer, and it worked also. But there can be also proof for this. You can prove that part. So the main question of this problem set is problem number C, which isn't a DB problem, or I can say there is a tag of DB, but I know it is a many kind of greedy problem. So I will make you understand how you can solve this problem number C with with proper proof also. So what is the approach? What is the right approach for the problem solving? So I will solve the problem using greedy method. I will not use any binary search DB or anything, but I will solve using greedy method, and I will show you proof why the solution is working on this problem. Right. So what is problem asking us to do simply? They are given us array A, and we have to divide array A into two subsequence, such that every element of my array A is either in one subsequence or in second subsequence. Now in both of the subsequence, I have to count the number of indexes such that my previous index is more than my current index, and the sum of both the subsequences will be my final answer. For example, you can say in this case, let my array A be like 1 3 1 4 1 5. So I can split this array into these two parts. So answer of these two parts will be individually added in my answer, and the sum of both will be my answer. Now that answer which I have to minimize. So what is the minimum sum possible from this array? I have to tell them. Okay. So how to approach this problem? So first of all, you might be thinking like I can thought of a LAS approach, that I will find the longest increase in subsequence and simply I will simply check all the numbers that are not validating. For example, you can say that this is my array like A, B, C, D, E, F, and G, right? So I can simply find the longest increasing subsequence from the back. So let's suppose my longest increasing subsequence like G, E, then A, B, and C. Okay. If this is increasing, which means if I go to like this, then which means my array is decreasing like this. Okay. Okay. My array is decreasing like this. So this is my longest decreasing subsequence. Okay, I will find that. Now the remaining part. My remaining part is G, D, and F. So what is the first approach which come to mind? Let I will simply find the longest decreasing subsequence and simply subtract that length from my final answer or final length. For example, the length of this array is 7, and the length of my this longest increasing subsequence is 5. Okay, so which means the rest of the part, which is not in this longest decreasing subsequence, is of length 2, which means my answer is 1, because you see I have two indexes, I can only compare one pair. So according to this the answer is 1, but it is not every time possible. Let me show you a case where it will not be a case. For example, let my longest decreasing subsequence is like 8, 4, 3, 1, and 2. Rest, okay, I can say it's 0 also. and rest all the number are increasing. Let's suppose my that number are hmm, wait a minute, I have to write it from here, right? 3, 4, 2, 1 and 0, right? So let's suppose my all the numbers are mm, are not part of this. So let's suppose the part the length which is not part of this, let it be like, for example, 3, 2, 1 and 3. So the remaining part, for example, this is my remaining part, 3, 2, 1 and 3. So if you decrease the length of my longest decreasing subsequence, which is 8, 4, 3, 1 and 0 from my length. Okay, what is my length? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So if I decrease the length of this from my 9, for example, this is 5, then what is my answer? My answer is 4, which means I will be having 3 pairs. So in this case, is my answer 3? No, the remaining string is like this. It is not always possible that the remaining string which I am getting will always containing all the pairs which are in decreasing order. For example, my 3 is greater than 2, which means it will not form a pair, right? My 2 is greater than my 3, which means this is also not going to form a pair. And my 1 is smaller than 3, which means this is going to make a pair. But in this case, you can see my answer is 1 only. But the expected answer using the LAS approach is 3, which is incorrect. So that's why LAS is not going to work in this question. Okay. So this is a proof why LAS is not going to work. Now, what approach is going to work? So you can simply use a greedy approach. For example, let me debug this test case. Okay. So this is a test case. So what is a greedy approach? First of all, I will try to reconstruct my both the subsequences. But how? How I can by using some number of operation. Okay, let's suppose my array, my first subsequence is this, my second subsequence is this. I can write it here, write this. So first of all, what I will do, I will simply put a maximum number in both the subsequence. I will tell you reason later. So I will simply put a 1 in 9 here also and 1 in 9 here also. Okay. So what I will do simply, I will pick my first number. Okay. I will pick my first number. Now I will check whether my first number is greater than my first array. Let's suppose it is array A and it is array B. Now I will check whether my first number is my greater than first array is greater than last number of array A or greater than last number of array B. Because which condition I have to satisfy? This is a condition, which means my B of I, which means this is a condition which I have not to occur. Which means if this condition is not satisfying, which means that is a good condition. Okay. Which means this is a bad condition, and the condition which I want to achieve is like my B of my previous B should be greater than my current B which I am adding. Okay. So what is my current number which I am adding? But the 8 is that number which I am going to add in A or either A or in either B. So in which I should add. You can see my both the number of A and B are greater than my current number 8, which means this condition is satisfying. So I can add either in A or either in B. Let's suppose greedily I will add in B. A. Okay. This number is added. Now my comes 2. Okay. Now here it will come 2. So 2 you can see my 8 is also greater than my 2. Yes. My 8 is also greater than 2. And my 1 in 9 is also greater than 2. So where should I put it? To get the maximum, so to get the minimum answer possible. So you can see, let me try to tell you one more case. Where should you put this? So let's suppose you have three numbers like 50. Let's suppose you have three numbers like, I think so, 50 and a number like 30. And you want to put 20 and you want to put 20 in the end of both of these. So where should I put 20? Because you see my 20 is smaller than my 50 and 30 also. So if I put 20 here, I can put 20 here. Okay. So where should I put it? So now you can see greedily what I will do. I will simply put the 20 in the end of smaller one. Right. I will put the 20. Where is my smaller back? So now 20 is greater than both of them are back. Okay. So I will check which is the smaller one. My 30 is smaller one. So I will put it in the end. Okay. So why I am putting it in the smaller one? This is also case. So what is a condition which I want to satisfy? I want to satisfy a condition like this. My b of I should be greater than of b of I plus 1. Okay, the number which I am adding. So I have to maximize this number as much as possible. Okay, so if I'm encountering another number like let's suppose 40. Okay, so I have two numbers like 20 and 40. Okay, I have two numbers 20 and 40. So where should first of all I will try to put 20 here. Okay, I will put 20 here. Now you can see my 40 is greater than my 20 also. Okay, and my 40 is greater than my 20, 30 also. Which means in both the cases I have to increment plus 1 in my answer. Okay, but this is not the case if I put 20 in the end of 30. Let's suppose I put 20 in the end of 30. Okay, I will put it here. Now I have two cases. My 40 can be here and my 40 can be here. So greedily what I will do, I will simply check whether my previous number is greater than my 40 or not. Yes, you can see here my 50 is greater than my 40. So I will simply put my 40 here. Okay. Now you can see in this case I will not add any of the number, which means in this case I will add 0 in my count. So now you can see it is beneficial in the case if my previous both the numbers of if my last number of both the arrays are greater than my current number, then I will simply choose the smaller one, the smaller bag, and put that number in the end of smaller bag. Because you see, the greater number which is left, it is going to help in future because it is greater. Because it is greater. Because there can be also number like 40 which is satisfying with 50 but not with 30, which means it is in middle of both of them. Okay, so I have to understand why I am putting the element in the smaller one case. So let's suppose I am back to my condition here. Here you can see I am having 2. So 2 is smaller than my 8 and 2 is smaller than my 1 in 9. So I will put 2 in the end where my 8 is lying, which is smaller one. So I will put 2 here. So I will put 2 here and this is cut also. Now I am at 3. Okay. Now you can see my 3 is now you can see my 3 is greater than my 2 and my 1 in 9 is greater is my 2 is smaller than my 3 and my 1 in 9 is greater than 3. So what I will do, I simply put it at the end of B because you see I have to make this condition satisfy to minimize this operation. So I will try to maximize this number of operation. So I will simply put in the end of B array. So where I will put B 3 in the end of B array. Okay. Now here come 1. So now you can see my 1 is smaller than both 2 and 3. So what I have tell you, I will put in the end of that number which is greatly smaller. So my 2 is smaller, so I will add in the end of 2. Okay. Now here come again 1. Now you can see my 1 is smaller than or equal to both the numbers. You can see my 1 is smaller than 3, my 1 is smaller than 1 also, or equal to. So I will put it in the end of that number which is smaller. So I will put it in the 1. Okay. Now 7. Here comes 7. Now you can see my 7 is greater than both 3 and both 1. Okay, so where should I put it now? I will use the same greedy algorithm. I will put it into that number which is more smaller. Like you can see my 1 is more smaller than 3. So I will put it 7 in the end of 7 1 also. Because you see, if at any point I'm encountering another 2. Let's suppose before 7 I'm because let's suppose I'm again having like 7 and 2. So if you put 7 in the end of 3, I put it here. Now you can see what is my 2. My 2 is my 2 is let's suppose maybe there may be another case. I will tell you like here. Here it is 7. So I will put 7 where my number is smaller than. For example, my 1 is smaller than 3. So I will put 7 where is my smaller number. That is 1. Okay. Now 4. Where should I put 4? So now you can see if I put my 4 here, then you can see 4 is my 4 is smaller than 7, that can satisfy. But if I put 4 here, then in this case my 4 will be greater than 3, so I cannot put it here. So I will simply put it Okay, wait a minute. Right. So where should I put 4? So what condition I have to satisfy? I have to satisfy a condition in which where my number of currents are minimum. For example, you can see if my 4 is more than 7 and my 4 is greater than my 3. So where will I put a 4? So I will put a 4 where it is a condition satisfying. So I will put it 4 here. Now remaining 3. So where should I put a 3? So I will put a 3 here. You know why? Because my condition is satisfying. Okay. So this will be my two arrays like this. So I will simply count how many times my number of my previous element is smaller than my current element. So you can see there is only one case like here only. My one is my here you can see in this case my one is more than 7. So answer in this case is 1. Okay. I hope so you have understood this much. So let me debug one more test case for you. Let's suppose my array is like this. So in this case what I can do, I can simply make two array initialize two array A and B, and initially both the numbers are 1 and 9. Okay. Okay. So my first number is, what is my first number? My first number is 1. Okay. Where should I put 1? So what were my condition? My condition was simply this. Okay. So but so where should I put 1? So I put 1 there where it is my where my this condition is satisfying. So you can see my 1 is more than both 1 and 9. So I will put it here only. Now it is son of 2. So where should I put 2? Now you can see my 2 is my 2 is greater than 1. My 2 is more than 1 and 9. So I will put it in the front of 1 and 9. Okay. Right, suppose. So I will move it from here. Okay. So I will put it here. So now here again 3. So where should I put 3? Now you can see my 3 is greater than my both 1 and both 2. Okay. So I will put it where there is my smaller value. For example, my 2, my 1 and 2. And my both the numbers are smaller than 3. So I will choose a smaller number, that is 1. So I will put it in the end of 1. I will put it here. Okay. Now here come 4 again. So where should I put 4? Now you can see my 4 is greater than both 3 and 2. So I will choose a smaller one, that is 2. So I will put it here. Okay. Now come 5. So where should I put 5? Now you can see my 5 is also greater than my 4, both 3 and 4. So I will choose a smaller one, that is 3, and put it here. Now I will count the number of inversions. Like you can say my number of inversions in this case like 1 3, 3 5 and 2 4, that is 3. Okay. So answer in this case 3. So let me tell you one more time that why I'm choosing only smaller number. For example, I will tell you one that test case again. For example, I have two arrays like array A and array B, and the last number of array A is like 30 and last number of array B is like 50, and I have two numbers which I want to add like 20 and 40. Okay, so now tell me, if I put 20 in the end of 50, let's suppose, but I am telling you that I will choose, if my both the numbers are greater than my current number which I want to add, then I will choose a smaller number and put my element in the end of that array. So in this greedily, according to me, you should have put it at the end of 30, right? Suppose, but I will not put it. I will put it at the end of 50, but that is incorrect. I know. But now you can see, if I want to add 40, but you can see in the case of 40, my both the last values are smaller. Okay, my both the last values smaller. So I have only one option. Either I can put here, or either I can put here. In the both of the cases, my number of inversions are increasing by 1. So in this case, my answer is 1. But if I put if I put my 20 in the end of 30, okay, I will put it at 30. Then my greater value is preserving. I am not discarding my greater value, because you see, my greater value will always be helping in my future. For example, in this case, my future is 40. So you can see my greater value is smaller. My greater value is greater than that value also. That's why my greater value will always help if I greatly don't put in the end of that number. So that's why I will put my current number in the end of smaller one, and I will put 40 here. Now you can see in this case my number of inversions are 0. So that's why. So this is our problem intuition of problem number C. I hope you have understood this much. If you have any doubts in this approach, you can comment me down. And please don't forget to subscribe my channel. Till this chat for the next one. Thank you.